Hi everyone. So this lesson is on something called a midpoint. So we're going to learn what a midpoint is and then how to use it, and also something called the midpoint formula. It's also on the coordinate plane, sort of like distance formula, but kids usually find this one a little bit easier. All right, let's get started. Okay, so first let's do the definition of a midpoint. So the midpoint of a segment is a point that divides the segment into two congruent segments. So we learned our very first lesson, congruent segments are segments that have the same length. So they're basically the same. Pretty much a midpoint is the exact middle point of a segment, kind of like cuts it in half. So if in this example here, it says the midpoint M of segment PQ. So let's label this P and this Q. Here's M, is the point between P and Q such that PM is equal to MQ. That's how you mark equal segments on a picture. So because M is the midpoint, PM is equal to MQ. That's what a midpoint is. Sometimes you might be asked to do an algebraic type midpoint question. So these directions say find X, PQ, QR, and PR if Q is the midpoint of PR. So notice there's no picture here. In geometry, if you're ever given a prompt like this with no picture, you always want to draw a picture. So I'm going to draw segment PR. And then it says Q is the midpoint. So Q is going to be in the middle. RQ is equal to QP. Let's label with the given information. So it says PQ is 6x minus 7. RQ or QR, same thing, is 5x plus 1. Okay, so the only thing we know about this picture is that those segments are equal. And so in geometry, sometimes you're asked to find X. You're given a situation like this, and you're asked to find X and then maybe some measures of the things in the picture, like the figures. So basically what you do is you want to set up an equation that represents what you know about the picture. So that's why it's important to draw a picture and label that picture, because then otherwise you won't know what's true about it. So what's true here is that this piece is equal to this piece because Q is the midpoint. So our equation that we're going to write is just going to be setting 5x plus 1 equal to 6x minus 7. They're equal to each other. And then you just solve for x. So if you remember solving for x, I know it's probably been a while. You want to bring the x's on the same side. So I'm going to subtract 5x. So we have 1 equals x minus 7. And then we'll add 7. So x ends up being 8. If it only asked us to find x, we would be done at this point. But notice it also asked us to find the lengths of the segments. So it wants us to find the measure of PQ, the measure of QR, and the measure of PR. So let's see, I'll do that up here. So to do that, we're going to take 8 that we just found and plug it in. So plug it in here for PQ. So what I mean by that is 6. See how PQ is 6x minus 7? Instead of putting x, we're going to put 8 because we just found x was 8 and then minus 7. And then we're just going to multiply. 6 times 8 is 48. Minus 7 would be 41. So PQ is 41. I'm also going to plug it in for RQ. I expect that to also be 41. So I'm going to do that over here. And I know they're equal because Q is the midpoint and I just set them equal to each other. 5 times 8 is 40 plus 1 is also 41. And then lastly, it wants us to find PR, which would be the whole segment. So we can just do 41 plus 41. So PR would be 82. Okay, that's how you do an algebraic midpoint question. Next is the midpoint formula. So if we were on the coordinate plane like we were for distance formula, and we were asked to find the midpoint of two segments, this is the formula. So again, you label your points with x1, y1, x2, y2, and then the formula is x1 plus x2 over 2. So you basically are adding your x's, divide by 2. It's like the average of the x's. And then same with the y's, adding the y's, dividing by 2, the average of the y's. And that gives you your midpoint. So here's our first example. It said find the coordinate C, which is the midpoint of TU, if T and U are at these points. So the first thing we're going to do is label the endpoints, x1, y1, x2, y2. Zoom in a little bit. Okay, the next step says to rewrite the formula. You don't always have to do that, but I like to do it. So I'm going to be plugging it in like right underneath it. So it's x1 plus x2 over 2. I'll do it the first few times, but I probably won't always do this. Okay, and then we just plug. So x1 was -2 plus x2 is 8, and that's over 2. And then y1 was 4 plus y2 is 10 over 2. So that's what it looks like when you plug in. And then you just simplify. So you want to simplify each numerator. So -2 plus 8 is +6. 4 plus 10 is 14. And then you do want to simplify it further if you can. Like these 2 goes into 6 and 14 evenly. So you want to keep going. If it didn't, you can just leave it as a fraction. It's fine. So the final answer would be 3, 7. 3 just looks a little weird. So 3, 7 would be, if I plotted these 2 points and this one, the midpoint would be right in the center. So that's midpoint formula. We're going to do one more straightforward example of midpoint formula, and then one where it's a little trickier, you have to work backwards. So first thing we need to do here is get the coordinates of x and y. X is at -2, 0. Y is at 3, -5. We just label our points, x1, y1, x2, y2. I'll rewrite the formula again, I guess. X1 plus x2 over 2, y1 plus y2 over 2. And then we plug in. So it's x1 plus x2, so it's going to be -2 plus 3 over 2, 0 plus -5 over 2. So if I simplify these, -2 plus 3 is 1. 0 plus -5 is -5. So you can either, here's what I'm talking about, if it doesn't divide evenly, you can just leave it like this. Or if you prefer decimals, you can do 0.5, -2.5. I'm fine with either one, doesn't matter. Okay, so that's midpoint formula. It's pretty easy, very straightforward. Sometimes though, like this last example, you're given an end point of the segment and you're given the midpoint, and then your job is to find the other end point. So that's what this one's saying. So the midpoint of segment JR, this is the midpoint. J, so one of the endpoints is 3, -4. So we want to know what are the coordinates of the other endpoint. So there are 2 different ways you can do it. One way, a lot of you could probably figure out, it's kind of just like a counting method. So I'm going to show you that way first, and then I'll kind of briefly show you the algebraic way because not many kids do it that way. So I'm going to just sketch something just to show you what this situation is. Say here's J and here's W. Obviously, this is not what it would look like necessarily on the coordinate plane. I'm just like sketching it randomly. So J is at 3, -4. W is at 4, -6. So W's in the middle. We don't know where R is. That's what we're trying to find. So we don't know what R is. So since the midpoint is the average of the 2 endpoints, it's directly in the center. So like the values of x are going to be right in the middle of the 2 endpoint x's. And so what I mean by that is if I look at from 3 to 4, so think about, how do I get from 3 to 4? What do I add to 3 to get to 4? Or subtract sometimes. I add 1 to 3 to get 4, right? So that means from the midpoint to the other endpoint, x value is going to be another 1 because it needs to be, this W is right in the center. So 4 is right in the middle of 3 and 5, right? So you just kind of figure out like, what do I add or subtract to get from one to the next? And then you do the same thing to get to the other endpoint. So same thing with the y coordinate. -4, to get from -4 to -6, think about what do? You subtract, right? You subtract 2. So to get from -6 to the other y coordinate, we're going to subtract 2 again, which is -8. So the midpoint values need to be right in the middle of the endpoint values. So I think that's the easiest way to do it. I can show you guys again if you like, but that's pretty much it. So your answer here is 5, -8. Now, the way to do it algebraically is you kind of like use the midpoint formula and work backwards. So I'll show you that real quick. If you're someone who likes a method and like an algebraic method, that works. So this is the midpoint formula. I'm adding in x, m, y, m because now we know x, m, y, m. Like if you look up here, this w is the midpoint, right? So that's really x, m, y, m. And this is like x1, y1. And we're trying to find r, which is, we don't know, but x2, y2. And so what you would do is you would plug the values you do know into the formula and then solve. So basically this little expression here, once simplified, equals this. So this is what you would set up. We said x1 was 3. We don't know x2, so you just write x2. But we do know xm, the midpoint x coordinate, is 4. See up in w? So then you could solve that for x2. So to solve that, you would multiply both sides by 2. And so you'd have 3 plus x2 over 2 equals 8. Just kidding. The 2's gone now because I multiplied both sides by 2. Sorry about that. And then we would now solve for x2 by subtracting 3. So see how I'm getting 5, which is exactly what I got up here for my x coordinate of my vertex. See how I got 5? Okay, let's come back and do the same thing with the y. I'm going to plug in y1 plus y2 over 2 equals ym. So y1 is negative 4 plus y2 over 2 equals the y coordinate of the midpoint, which is negative 6. Okay, and then we solve for y, so you're going to multiply both sides by 2. So then you have negative 4 plus y2 equals negative 12. Add 4 to both sides, and you get negative 8. So it's the same thing, just a little more work. So I don't know. A lot of kids don't do it that way. Usually we do the counting method. So yeah, so that's it. You're going to try a few of both in the practice today, and just let me know if you have any questions.